Hi everyone, my name is Anvita Bansal and we are back with another lecture based on Linkedlist. I'll just connect this one. Okay, so let me quickly check if you guys are able to see my screen. Yeah, we are live. Okay, so the problem that we will be discussing today is reverse linked list, as we started off with linked list yesterday. So let's have a look how can we solve this problem. This is also a basic one. Let's understand it. Okay. So see, you are given a linked list and you have to reverse the linked list. Now, what do you mean by reversing a linked list? See, this is how your output. After reversing linked list, it should look something like this. Okay, I'm sure you are aware of reversing things already. For example, be it anything. Now, I want to reverse a linked list. So the major difference that will come will be in the head that you are finally going to return. See, the head of the linked list right now is 1. Head is pointing to 1, right? What the linked list that I'm writing here is, let's say, like this. When I want to return linked list, you know this is the tail of the linked list and its next by default is going to be null. We know that. We are not explicitly mentioning it, but we know it. When I'm reversing the linked list, how it should look like? Actually, these pointers would be reversed and your new head would be this. So actually it should look like this. 5, when it reverses it will point to 4, 4's next will be 3, so on and so forth. 3, 3's next will be 2, 2's next will be 1 and 1's next will be null. Basically your head, new head becomes your tail which was there in your original linked list becomes a new head, and your head in the original linked list becomes your new tail. That's what you are needed to do. Now, as our question says, we are reversing, so we are actually creating a difference in the pointers. How the nodes were pointing previously, they are pointing exactly opposite now when we are reversing the linked list. So how can we reverse these pointers? Let's start off. This is my linked list. I'm taking the original one now. Okay, fine. Let's have a look. We can make use of 3 pointers here. Let's say your node, there is your node current which is pointing to your head. Okay, then there is another node, let's say node previous, that will be pointing to a node just before head. Right now I'm initializing it to null. In the loop we will be doing this, so we can do it in 2 to 3 ways. What I'll be discussing will be iterative one and the recursive one. So the first one is your iterative one. What are we going to do? I am taking pointers here, 3 pointers, current, previous, and let's say this is your temp pointer, which will apparently be the next of your head. It will be pointing to the next of head. Initially I'm initializing it with null only. Now let's see in the iteration how it is going to look like. I want to reverse the links, right? I want to reverse these pointers basically. So right now my current is here. Fine. What I want to do is I want this current to point to its previous pointer. For that, what can I do is, first of all, let's do one thing. Right now my temp is null. Let me make my temp. Now this is where I am in the loop, and this loop will go till where we will see once we are done with the iteration. You will yourself understand that this while loop should go till where. Okay, the first thing I want to do is, now I want this temp node and the previous node to be at their right position so that I can change the pointers. I basically want one to point to null, but when I will point one to null, you know that this pointer, this link will be detached. This link will be removed. Why? Because it's a singly linked list. Once I am pointing one to null, obviously this link will get removed. So if this link will get removed, how will I access 2? That is the reason I have taken this temp node, which will apparently be accessing the next of current. So temp will become equal to cur.next, right? Before doing anything, I am doing this stuff so that we can have the exact pointers wherever we want. Now the next thing I'm doing is, see, right now this is your first iteration, so I know that 1 should be pointing to null. But what if when I will come here, in that case 2 should be pointing to 1. when I will be here, 3 should be pointing to 2. So I should have the address of my previous node. So that will be handled using previous. So what I am going to do is I am going to make cur dot next will be pointing to previous. So in this, so far what we have done, I'll just show you the exact things that are happening as we are writing these cases. So initially your cur was at 1. Fine, you made cur point to 1. Now your, with this pointer, your temp is present here and your cur dot next is previous. So cur and previous was at already null. So this was where your previous was. Now 1 is pointing to null. So this link has been removed. Okay, this link has been removed. Let me just erase it. Okay, now this is how your linked list is looking like. Next thing what you should be doing is, that your temp dot next should be pointing to cur. Is that right? Okay, let me make it like that. Now cur dot next is previous. Fine. Before doing that, let's do one thing. Now I want to do, this is the iteration. Now I want to repeat the same things for the rest of my nodes. Correct? So temp pointed to cur dot next, which got me here. Then cur dot next is pointing to previous, which got me here. Now let's do one thing. Let's change their addresses. Now previous will be at pointing to current. This is where your previous will be, and cur will be pointing to temp. And then we will repeat the same processes. So previous is equal to, basically now previous is present storing the address of your current node, and current node is storing the address of your temp node, and cur becomes equal to temp. Now you see for the second iteration, let's try one more time. For the second iteration, how is it going to look like? Right now your linked list is like this. Fine. Okay, previous is pointing to 1, cur is pointing to 2, temp is pointing to 2. Let's see, temp is equal to current dot next. Current is 2, so cur dot next is 3. So your temp has come here. Okay, current dot next is previous. So cur dot next, that is 2's next, will be pointing to 1. So this link will be removed. Let's remove this link. Okay, now previous is pointing to current. So this is, let me erase it. Now your previous has moved from there, your previous has moved from here, it is pointing to here, and cur has moved from here to here. Now same steps. So I am doing this while my cur is not equal to null. See, let's keep doing it. Now your 3, for the next iteration, temp is current dot next. Temp from here will move to here. Current dot next is pointing to previous. Okay, once you have made this link, you are going to store the addresses. You are going to change the addresses of previous and current. Previous is going to come at the place of current, and current will go at the place of temp, so that I can repeat the same process. See, now the link of 4 to 3 will be formed by doing cur dot next equal to previous, and before that I have already moved temp to 5. Okay, so 4 is now pointing to 3. Cur dot next is previous, 4 is pointing to 3. Now change the addresses. Previous will come at the place of current. Current will go at the place of temp. And now for the next iteration, your current is still not equal to null. Move your temp to what? Cur dot next. Temp is pointing to null. Cur is pointing to 5. So this will be reversed. This pointer will be reversed, and it will be pointing to 4, right? Okay. So this is pointing to 4 right now. And current will now change the positions. Previous will come at this place. Current will go at temp, that is null. This is your current pointing to. Now when you check, your cur is equal to null. Cur is pointing to null pointer, right? So when you formed the link from 5 to 4, that time itself this link was detached. This link was removed because it's a singly linked list. So finally, tell me, your previous is pointing to your new head. Once we are done with the iteration until your current becomes equal to null, you see that you will come out of this loop only when current becomes equal to null. So that means previous would be present at your new node. So finally coming out of this loop, you return previous. That's the head of your newly formed linked list, that is after reversing. Okay, I'll just quickly check if you guys have any doubts. Okay, so I think that's okay. Now let's try to code by using this method, and then I will move on to another method, that is recursive one. Okay, so see what we did. We took 3 nodes, node temp equal to null, node head equal current equal to head, okay, and node previous equal to null. Okay, so you are doing all of these things while your current is not equal to null. Okay, cool. What are you doing? You are basically making your temp point to cur.next, then you are making your current point to previous node, so cur.next equal to previous. Fine. Now you are changing the positions, you are changing the addresses of previous and current. So previous will come at the place of current and current will go at the place of temp. That's all. And you know, by the end of iteration your current would be pointing to null, but your previous will be pointing to the new head of your linked list. Let's submit it. And now I am going to discuss the recursive approach, which also you need to understand. Okay. Fine. We have done this one. Let's talk about the recursive approach. So in your recursive approach, what are we doing? Let's discuss about it. In the recursive. Fine. Let's again create the linked list. So what do we do in recursion? We try to solve problem for a smaller subproblem and we expect recursion to give us the answer for the remaining part of the problem that we are trying to solve. So in this case, we can see that we can take recursion function or recursion call to be like this, that for example, if this is my entire linked list, so I will expect my recursion to give me this linked list, the new head of this linked list. Basically I will expect my recursion, I'll make a recursive call, let's say func will be called initially for what is the head you are passing. The head you are passing is 1. Okay, so what I'm expecting is that it will divide your linked list into 2 parts, that is 1 and the remaining part of the linked list, and I am expecting my recursive function to provide me a new head for this particular remaining linked list, and all the nodes of this linked list are actually pointing to each other in the reverse manner. That means I will expect, I have made a call from 1, right? When I made a call from 1, the recursion will actually provide me remaining linked list like this, the way I am expecting it to be. But it is not happening in just one pass, right? Not one pass, in just one call. This is not going to happen in one call. Why? Because when I called for func1, the remaining linked list was 2, 3, 4, 5. So your new head now is 2. Okay, so 2 will expect that recursion will give me the new head of this remaining linked list and the links will be reversed. So for that, another recursion call would be made where your current head will be 2, and I will expect this func2 as a recursion call to be returning me the remaining linked list in the reverse order. But since we are dividing the problem into smaller subparts, that's how recursion works. So next call will be made for func3. Now this part is remaining, so from here, so what it will say, okay, I will ask remaining linked list to do that work. I am the new head now, so func3 will be making call for recursion where 4 and 5 are expected to be returned by after reversing links. So I am expecting that it will be like this. Okay, this is what func3 will expect, but func3 has remaining linked list whose new head will be, means head will be 4. So 4 will say, why not ask the other remaining linked list to do that task for me. So each one of them is dividing itself into smaller subpart. Now when I am at func5, okay, so at func5 you have only one node. Okay, when you have only one node, even on reversing single node, you are going to get that node itself. So that is where you realize that your base case will be if either your head is equal to null, okay, or your head dot next is equal to null. either you do not, either you have the null node or you have only single node. In both the cases, what you should return the head itself, because on reversing 5, what are you going to get? You're going to get 5 itself. So while if head equal to null or head dot next equal to null, this is your base case. You should be returning head, return head. And for the remaining part, see, for the remaining part, what are we doing? We are expecting that all the, when I am for, let's assume I am at func1, so when the recursion calls must have been made and these would have gotten their subsequent answers, what must be happening is that I am expecting that recursion func1 will be expecting that all this remaining linked list must have been reversed. So if it must have been reversed, this is how it is going to look like: 2, 3, 4 and 5. So in this case, obviously your last node means last node is 2. So I need to get address of this node somehow. How will I get the address of this node? You see, this node is exactly what is your current head. I'm talking about func1. Just focus here. Just helping you understand how to do the remaining work of the recursion. So in order to do this, we are doing basically keeping a faith here that recursion must have reversed all the links, and this is what I need to do. What I need to do is that this tail should be pointing to 1 so that I can get all my work done. So the recursion would have done this part, but for func1, current head is 1. Okay, head dot next is 2, right? So I can get the address of this node by pointing to head dot next. Basically what I want to do is I want to reverse this link, right? So I can do one thing. The remaining part would be, you can say how to point at this node. This is, let's say, node, you can call it anything, let's say node tail. Okay, that is equal to what? Head dot next. Fine, this is equal to head dot next. And before that, see, this is your basis condition. Let me write the pseudocode itself so that you can understand it properly. Okay, so this is your basis condition. I am making a call to recursion. So let's say this is your reverse function, reverse, and you are passing your head. Okay, so reverse must be returning you some new head, which is actually, for example, in this case will be 5. This is your new head. So let me take node new head equal to reverse head. This is what I am expecting my recursion to give me. That is the head of your reversed linked list, new head. Okay, now my next thing would be to change this link from here to the actual head that I called for my recursion. Okay, so the next thing that I'm going to do is head, it's this head dot next is actually 2, right? And its next I want to be pointing to head itself. And finally this will become your new tail. So new tails next would be what? Null. So make it now your head dot next should be pointing to null. This is the remaining task that I will do for the recursion, and that's how my entire linked list will be reversed. And finally you return what? You return new head. Okay, new head. That is your reverse function. Reverse node head. Okay, I hope you understood this problem. So the difference between the two approaches was, in iterative also we were doing it in one pass. It was taking O(n) of big O of n time complexity. In recursion also we are accessing each node exactly once. That is also taking O(n) of time complexity. The only thing is extra call stack space that recursion by default uses. O(n) of that extra space, nothing else. Okay, so let's go on to the code. I'll just quickly, because sometimes this recursion approaches is something what people struggle to understand. Just one more dry run I will do so that you can understand on the smaller level. So for example, you had 1, 2, 3 and 4. Okay, so 4 next was null. You made a call to reverse, so node of 1 was called. I'll write it here itself. Okay, reverse function. Just one quick dry run so that if you have any doubts, that will be cleared. Okay, 1 second. Fine. So this is your reverse function. In your reverse function, head was initially 1. This is your head. So this was passed. then it is not equal to null. So you go to the next line of code. Your new head is equal to means we are making a recursion call. So your new head basically is making a call to recursion again. So I am making a call to reverse of head, which is what, another one. I think the head dot next, it's a mistake I made, it should be head dot next. I made a call, I started with one, now I'm making a call for another one, that is head dot next. Again it is not equal to null, in this condition it does not satisfy, so another call will be made, that is for reverse of head dot head. Initially was 2, now it will be 3, same thing will be followed for 4. Now wait, when I am at this call, when my head is pointing to 4, okay, your head dot next will be null in that case, so it will be returning head. Now this head will be returned to the call that made it. So new head was here, it must have called it. Actually new head is storing the answer that I got from reverse of 4. This call returned me 4, so new head will be stored with 4 now. Got it? And for this case, let me just do not here. So when you made a call to reverse of 4, there is a new head that your function must have been expecting. Okay, so it returned head. So this head will be actually, so this reverse 4 is returning 4 to your reverse of 3. What answer is it? New head it is returning, because we are returning new head actually. So it is returning 4 as a new head to your reverse of 3. What are the subsequent steps for this call? Now you have to do certain things, which are actually you returned 4 to this function. Now this was your head for this reverse of 3, this was your head dot next basically you want 4 to point to 3. So now this link will be removed and it will look like this, that 4 is pointing to 3, correct? And this link will also be removed because it's a single linked list. Now this is how it is going to look like, and head dot next equal to null. So this is how your reverse linked list is going to look like. Fine. And you are returning new head. What was your new head? New head was what? Your new head was 4. So 4 will be returned again to this one. New head will keep on passing to the subsequent calls that made it. Now let's solve the remaining statements for this recursion call. Again, I am at this point where I made a call from 2. What are the next steps of it? Head will be what? See, now I'm at this point. Okay, at this point your linked list looks like this. Your head is 2, so head dot next, your head dot next is 3, correct? When I was at this stage, your head dot next was 3, so its next should be pointing to 2. Got it? So this 3, instead of pointing to null, it will be pointing to 2 now. This is how I am reversing it. And head dot next, this is pointing to null. Okay, so return your new head. So new head is still 4, it will be passed on to 1. Now 1 dot next, okay, what is 1 dot next? That is 2. So 2 dot next is pointing to 1, and finally 1 dot next will be equal to null. And that's how you are reversing your linked list. Done and fine. So let's quickly move to the code and code it using recursive call. So what are we doing? As I told you, our base case function is if my head equal null or my head dot next equal to null. In both the cases, in either of the cases, you return head itself. Next thing is you make a recursion call. When you make a recursion call, you are storing the new head equal to reverse list, and what are you passing? Head dot next. That's you are doing that for the smaller sub problem. The next lines of this function call would be that you are making your head dot next to point to head itself. Dot next equal head, right? And the head dot next will be null, which supposedly means that this is your new tail of the reversed linked list, correct? And then finally you return new head. That's all. Let's see. And we will be done with it. Good to know that it's clear to you, Ashla. I'll just check. Fine. So, fine if you understood it. That's all about this problem. If you guys have any doubts, you can ask me. Otherwise, I'll just wrap it up. Fine. Okay, guys. I hope you understood the problem. This was a basic. This forms the basics of your linked list. That is why these are smaller problems, and we discussed it using iteration and recursion. There is another way also where you're using a new space, that is space of a stack, and this is a hint I'm giving you. Try to do using stack also, because we have solved problems using stacks and queues, so I'm sure this is going to be very easy for you. Okay, fine everyone, then wrapping this up. See you all in the next lecture.